Hello, everyone. So I'm Alvaro. I'm head of research and development at Tesla Lab. And well, the introduction has been made. I'm going to talk about relevant KPIs on the audio spectrum this time. And let's go jump for it. So first of all, we have why is objective audio metrics important for your solution. We do that so that we get relevant metrics. Then what are the audio quality algorithms, different AI implementation, training the algorithms, and of course, the reporting and different solutions to do such thing. Well, first of all, why are they important? And well, this is kind of obvious. If we don't have reliable objective metrics to measure the quality in the receiver end, and when you do audio video calls, when you do streaming of any kind of media, if you don't get these objective performance metrics, you don't know how to compare it, and you don't know like how the progress on your new codecs or on your new implementations of SDKs and whatnot, how are they affecting the overall performance of this application. And the other thing is normally when we are talking about applications, we tend to think of them working in the ideal scenarios. But what happens if we apply network limitations, packet loss, jitter, and we need to know how much does that affect to the different video or audio. This is also why one of the reasons why we try to get the best metrics for measuring quality. And also, you need to know whether your application actually is better than the competition, so that users migrate to use your app. And well, we have the different relevant information you can get is overall quality, MOS. So it's kind of the 5 stars that you get after a call, and you say like, how was the call? And you say like, well, 3 stars or 1 star because you couldn't hear anything. And we can get that from objective algorithms, so objective metrics that you test once and again, and you get the same result if it's the same quality. Then you can get also audio delay, jitter, speech quality, and noise cancellation performance. But of course, some metrics work well for some specific applications, some work better for others, and I'm going to talk about those as well. Here we have 3 different algorithms that in Tesla Lab we use quite often. 2 of them is POLQA and ViSQOL. If you know anything about audio quality measurement assurance, you will know these 2. One of them, POLQA, is a licensed tool that it returns among different things a MOS score that goes from 1 to 5, and is full reference algorithm. Full reference means it needs the reference sample to be compared with the degraded one. And both POLQA and ViSQOL developed by Google, work in this way. So you always need the reference file to be able to get information. It's the good part of doing full reference is that if you have completely in sync the reference and the degraded sample, so both of them enter at the same time to, let's say, like an audio card, then you can get the audio delay between both reference and degraded samples. And this is very good information for audio video calls, because that way you know how much time has gotten from the sender, like the person talking, and the receiver listening to that person. And normally, what we say like is standard for good quality or understanding to the person, it's something around 0.5 seconds. If it's 1 second, it's still, you can work with it. If it's more than 1 second, the conversation is going to go down. And then we have ASQ-ViT, which is an audio to spectrogram and using a visual transformer. We have developed this in-house, and it's a classification algorithm that uses a convolutional neural network and a transformer on top of it. Transformer, like if you think about ChatGPT, that's kind of like the AI structure that is involved in that. And only with the degraded sample, we can get MOS score. And this is pretty good for some cases that I'm going to showcase very soon. Let's add two more audio quality metrics. In this case, this will be SpeechQ. It's another algorithm that we use for pretty much measure intelligibility, meaning we don't care about the audio quality itself. We only care that we can understand the speaker. And we use Whisper AI to be able to obtain the transcoded audio. And we compare the reference with the degraded samples, and then compare the text in this conversation. If they match, then we have a higher score. If they don't match, then we have a lower score. Does it correlate with MOS score? Yes, in most cases, but the correlation sometimes depends on, if you really need to listen some nuances of the dialogue of the person that is talking. But as long as the speech, you can understand it, then for audio calls, it's perfectly fine. And the last one that I am presenting is DNS-MOS. This is an algorithm that is developed by Microsoft. And it works very similar as the ASQ-ViT. And, correlation of ASQ-ViT and POLQA is very, very good. And this is for those cases where the degradations are due to the network. And then on the training data, we have a balanced data from very low scores to very high scores. So we need to curate the data before we train the models. And but here we have non-correlation between POLQA and ASQ-ViT. And why is that? This is because in a lot of applications, the degraded sample might not be degraded, it might be enhanced. It may be that they have removed the noise. And if you use POLQA or ViSQOL that are full reference and you remove the noise from the degraded one, then the score is going to go down because it's not anywhere similar to the degraded sample. But that doesn't mean that it's bad audio quality. And that's why non-reference algorithms works better in these cases. And eventually, this is the setup that we often work. It's an actually end-to-end setup that we have receiver and sender device. They can be mobile phones, they can be desktop, whatever platform. But the important part is that we do test the full end-to-end, and then we can get these metrics. And the last thing, but not least, the reporting solutions. The last thing that is really important during testing is to compare what happens with the audio quality scores to the network consumption, to the video, so that we can have a correlation between those metrics. And this is it.